Hi friends! Today we're going to be comparing fractions. As we do, we'll be finding common units or the number of units as we compare. Think, which is greater? 1 apple or 3 apples? 3 apples is greater than 1 apple. Think, which is greater? 3/4 or 1/4? 3/4 is greater than 1/4. What do you notice about these two statements? We can see that the units are the same in each. One is apples, the other is fourths. We can compare the number of fourths just like how we compare the number of apples. It's easy to compare when the units are the same. Let's try another. Which is greater? 1/4 or 1/5? 1/4 is greater than 1/5. How do we know that this statement is true? We can prove that it's true by drawing two tape diagrams to compare. We can partition a whole into fourths and the other tape diagram into fifths. Here we can see that there are more fifths than fourths, so each fourth is bigger than the fifths. 1/4 is indeed greater than 1/5. Let's think, which is greater? 2/4 or 2/6? 2/4 is greater than 2/6. Just like before, we can prove it by drawing two tape diagrams to compare. We can partition our first tape into fourths and the other into sixths. There are more sixths than fourths, so each fourth is going to be bigger than the sixths. Let's look back at the last two statements we just wrote. 1/4 is greater than 1/5. 2/4 is greater than 2/6. What do you notice about these two statements? In each comparison, we can see that the numerators are the same. We know that fourths are greater than fifths and sixths. Which would be greater, 2 inches or 2 feet? 2 feet. I know this because feet are greater than inches. In the same way, 2/4 is greater than 2/6 because fourths are greater than 6. When the numerator is the same, we look at the denominator to reason which fraction is greater. The greater the denominator, the smaller the fractional unit. I want you to go ahead and pause the video here to compare 5/7 and 5/12. Explain why 5/7 is greater than 5/12 of the same whole. When you're ready, go ahead and come on back and we'll compare our explanations. So how do you know that 5/7 are greater than 5/12? We know 7ths are greater fractional units than 12ths. 5/7 are greater than 5/12 because 1/7 is greater than 1/12. Let's now compare the two fractions, 2/8 and 4/10. We'll start by drawing a tape diagram to represent each fraction. Let's now go ahead and partition the 8ths in half. When we do this, what fraction is now being shown? 4/16. Now we can see that the numerators are the same. So we're now going to compare 4/16 and 4/10. We can see that 4/16 is less than 4/10, since 16ths are smaller units than tenths. I can compare the size of the units because the numerators are the same. So 4/16 is less than 4/10. Let's now compare 2/8 and 4/10. 2/8 is less than 4/10. The next two fractions that we're going to compare is 9/10 and 3/4. I'd like you to go ahead and pause the video here to come up with a strategy for comparing these two fractions. We'll share our ideas when you return. What strategy did you come up with? I was thinking that we could make a common numerator of 9. We can do this by multiplying both numbers, the numerator and denominator of 3/4, by 3. When we do this, our fraction is 9/12. We can now compare the fractions 9/10 and 9/12. We know that 9/10 is greater than 9/12. Therefore, 9/10 is greater than 3/4. The next two fractions we're comparing is 7/10 and 3/5. In this instance, can we make a common numerator just like we did in the previous problems? No, we can't. We can't multiply 3 by a number to get 7. Since finding a common numerator does not work so easily here, let's instead look at the denominators. Can we make like units with the denominators? Can we make common denominators? Yes, we can partition each fifth in half to make tenths. Now we can compare 7/10 and 6/10. we can clearly see that 7/10 is greater than 6/10. In other words, 7/10 is greater than 3/5. Let's try to solve this problem a different way. We'll use a different model. This time, we'll draw a number line and we'll clearly mark where 3/5 is. To make this number line, I'll have an endpoint of 0 and 1. We'll start with 3/5, so we'll mark where 3/5 would be. I'll need to partition it into 5 parts. So 1/5, 2/5, 3/5, 4/5, and 5/5. 1/5, 2/5, 3/5, 4/5, 5/5, or 1. 3/5 is right here. Next, I'll decompose the line into tenths to show where 7/10 would be. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. When we do it this way, we can compare 6/10 and 7/10. We can clearly see that 6/10 or 3/5 is less than 7/10. So 6/10 is less than 7/10. 7/10 is indeed greater than 3/5. For today's problem set, your must-do problems are here on the screen. Go ahead and set a